My cat has come to, oh, there he is. He's come to check out what I'm up to. Okay, here's an older cord. I wish I had a brown one. This one's kind of a white one. But it'll of course do just fine. How about that? This is Draper. This guy is a Norwegian forest cat. And he is a strong one. He's Mr. Muscle. He's about 1.5 years old. He weighs 16.5 pounds. He's one solid chunk of muscle. He loves to climb things, which is maybe where the forest end of it comes from. And he seems to have a little bit of interest in vintage radios too, especially sniffing them and rubbing up against them. So, you gonna stay here for this? Yeah. He will lose interest. He's pretty fickle, this cat. Okay. Oh, what am I doing? I still need to put the cord on, for crying out loud. I got kind of sidetracked by the cat. Okay, so doesn't look like the best connection job done by the last person. Yeah, I can't move these wires very far. We're going to have wire problems now. In particular, a shielded wire is a real problem to move. If you have a shielded wire and it's gone hard, and you move it, there's a chance the internal insulation will crack. And at a bend or somewhere like that, bend or the termination of the wire, a short circuit will develop. These wires, if you bend them and ruin the insulation inside, then nothing immediately happens. The wire stays conductive, and the rubber part of the insulation becomes kind of crumbly and that, but it's inside this covering, this cloth covering. So a little bit won't matter. Now, Draper's about to find out how hot my soldering iron is for me. So if we hear a yelp, what he's actually doing, he's looking for something to knock onto the floor. That's what I think he's really trying to do. There we go. Need a hotter soldering iron here to. There we go. see if I can get some of the excess solder off of that. Turn my soldering iron up a little bit. A little more heat. Whoops. Oh, there's not much solder left on it. The other connection looks okay. Okay. Now I don't have any particular strain relief on this. You know, this one came with this little, I don't know, grommet or whatever you want to call that. That was strain relieving the cord. This one, don't see any easy way to do it. Now, it turns out this camera I'm using now, the video camera to do this, works best in low light. Now, what looks fairly nice, at least in the monitor I'm looking at, light-wise, in the view of the video camera, in my eyes, this is dark. It's dark in here. So that would be a lot better. But you see, that's too much light now for the camera. I have to do something for strain relief, so I'm going to put a knot in the wire to begin with. It's something anyway. Now, I pre-tinned the wires, as you saw, and that'll avoid getting a big rat's nest of wire around here. The last person didn't do that, and they ended up with literally a rat's nest of wire there. And this wire is blocking my view here. Come on. That's about as far on as it's going to go. Now I can see. There we go. Okay, we'll solder that. There we go. That's a nice connection there. I'll just nip off this messy end and I can get right through the hole. It's pretty hard to bend this wire, you know, once it's tinned up. There we go. That's very good. There we go. Okay. Okay, let's see. Who knows? When do you think the last time was this radio was plugged in? Oh, I don't know. Let's check out some light bulbs here. 47. Oop. It's a 47. It's good to make sure the light bulbs are good. Okay, if the bulb's good, you'll hear that. That one's no good. That one is good. And I need a 47. I'll leave the box out. Okay, throw away the bad one. The reason you want to have light bulbs operating is because they often form part of a current limiting circuit with the tube heaters. And so often on these radios, when you turn them on, you see a big flash go in the light. And that flash is the light taking the shock of the current initial inrush current, because it's a lot cheaper to burn out and change a light than it is to burn out a tube. And these lights are both burned out, you don't get that effect. Now this radio's got a transformer, so it may not even be true at all. Or it may be an independent winding for these lights. They have nothing to do with the tube heaters, but offhand as I'm sitting here, I don't know. Anyway, it's always nicer with the lights. You need the lights. Let's let it rip. Let's see what happens here. Okay, now switches are off. Switch is off here. Let's put one bulb in the circuit. That's for maximum limit. Supply voltage today, 123. We're all set. Here we go. Okay, nothing terrible has happened. You can see it back here. The test lamp is lit. The voltage at 80%. Falling, which means the plate current is beginning to flow, which means a B plus is present. Not a lot. Rectifier tubes heated up. Not a sound out of the radio yet. Not a sound. Okay, let me listen. Not a sound at all. Let's turn it up here and see what happens. There is some noise in there. Okay, let's give it the full voltage here. How about that? Okay, we don't know what band we're on. I'm gonna guess we're on a shortwave band. How do you know what band you're on? Okay, the band switch is labeled here. AM 312519. So I turn the switch all the way this way, it's on AM. So let's do that. I overlooked doing a little chassis voltage check. Ooh, what's with that? That's pretty strange. You know what? There isn't a day that goes by where I don't do this work, where something happens and I think, what? How can that be? Watch this. I'm taking this neon bulb. I'm just checking the chassis for voltage. One finger on one lead. I touch it here. I touch the same chassis over here. It's the same chassis. doesn't light. How can it be touching the chassis in two different places causes such a big difference? Let's try it with just this. Very interesting. I mean, the chassis is a big conductor. I'm going to guess there's some kind of grounding thing going on here that's not right, but it's just a guess. Okay, so we'll turn the volume down. Turn this. Okay, so that's AM. And there's our familiar. Look at that. Works well. It's not even humming. This is odd. I had noticed earlier that the spring clips here have no spring on it. And the spring is actually here. The string is quite tight. I don't get that. It's as if the spring has come unconnected and slid all the way to the hole. But that being the case, you would expect this string to go slack. The string is wound many times around here. Okay, so I think what's happened here is I'm going to take a guess that a previous repair guy to solve the slipping string wanted to wind the string around the bobbin here a few extra times and found the slack by releasing the spring and letting it come all the way up to here. I don't know. Or somebody with no clue what they were doing took up the slack in the string by winding it multiple times around here. I'm tempted to take one turn off and connect that spring back myself. We'll leave it for now because it's working. Very good. I think all we got to do now is really just set up for an alignment. See if we can pick up the radio at all. I'll have to try and get a schematic for it. So that's the checkout. Amazing. See you in the next video.